You know that feeling you're in a Google Doc and you see someone else's cursor just typing away in real time? It kind of feels like magic. But have you ever wondered how that actually works under the hood? Well, today we're pulling back the curtain on a system called GenosDB. It's designed to solve this exact problem, keeping everyone perfectly in sync and doing it securely, all without a central server. So let's dive in and see how they pull it off. So right off the bat, this is the core puzzle. I mean, if you don't have one single source of truth, how do you stop things from becoming a total mess? How do you make sure that my change and your change happening on two different computers at the same time get put together in the exact same order for everybody? If I type hello and you type world, how does the system guarantee we all end up with hello world and not world hello? It's a tricky problem. And this whole challenge, it has a name. It's called the distributed data dilemma. Honestly, it's one of the toughest nuts to crack in computer science. But the way GenosDB solves it is, well, surprisingly elegant. It uses this really clever two-part strategy, and we're about to jump into the first piece right now. Okay, so meet part one of the solution, the high-speed delta sync. You can think of this as the system's default mode. It's what's running 99% of the time when we're all online and collaborating. And it's built for one thing, and one thing only, just pure blazing speed. GenosDB, or GDB for short, is smart. It actually has two different ways to sync data. Here's a good way to think about it. The delta sync, that's like texting a friend a quick update. It's fast, it's small, and it's perfect for that back and forth conversation. Now the full state sync, that's more like sending them your entire chat history after they get a new phone. Yeah, it's a bigger one-time thing, but it makes absolutely sure they have the complete picture. The best part is, the system is smart enough to know which tool to use and when. So let's actually walk through how this super-fast delta sync works. First, any change you make, no matter how small, gets logged in a local list called an Oplog. Every single entry gets this special timestamp that's really good at keeping everything in the correct order, even across totally different machines. So when your app wants to sync, it just pings its peers and says, hey, what have I missed? The other computer then figures out just the changes you need. That's the delta. Zips up that tiny little bundle of info and sends it over. It is incredibly efficient. And that, right there, is the payoff. Because the system is so good at sending only what's new, it feels instantaneous to you, the user. This is what makes that real-time collaboration feel so incredibly smooth and just reliable. Okay, so Delta Sync is fantastic when we're all connected. But what happens when you go on vacation for a week? You open up that shared document and there are hundreds, maybe thousands of changes. Your little list of updates is just hopelessly out of date. And for that, the system needs a safety net. And the system is smart. It automatically knows when to deploy the safety net. It triggers that full state fallback in two very specific situations. One, if you are so far behind that the other peers don't even have a record of your last update in their recent history. Or two, if you're a brand new user connecting for the very first time and you have, well, no history at all. So here's what that safety net process looks like. Instead of sending tiny updates, an up-to-date peer just sends its entire dataset, the whole shebang. The computer that was offline then does what's basically a total reset. It throws out all of its old, outdated information, completely clears its local history, and fast-forwards its internal clock to match the new reality. It's like a complete fresh start that brings it perfectly and instantly up to speed. This two-part approach, fast deltas backed by a full-state safety net, gives us this really powerful guarantee called eventual consistency. What that means is, no matter how long you've been offline or how messy the network gets, the system promises that, eventually, everyone's data will all converge to the exact same state. It's a powerful promise. Absolutely no one gets left behind. But look, getting everyone in sync is really only half the battle, right? I mean, what's the point if the data isn't secure? This is where GenosDB gets really clever. See, security isn't just some feature they bolted on at the end. It's woven right into the fabric of the data's journey from the very beginning. It operates on what's called a zero-trust model, which just means nobody is trusted by default. The heart and soul of this is something called the security manager. You should think of it like the central nervous system for all things security. It's the component that intercepts every single piece of data and asks the tough questions. Who are you, and are you really allowed to do that? The security manager's entire job is built on three simple core pillars. First, it establishes your identity using rock-solid cryptographic proof. Second, it handles authorization by enforcing exactly what you're allowed to do. And third, it guarantees privacy through some really powerful encryption. Now, your identity in GDB isn't just some username and password that can be hacked. It's an actual Ethereum wallet that you and only you control. Just think about that for a second. This is what we call a sovereign identity. It means you truly own your digital self, not some big tech company. And it uses modern, secure stuff like WebAuthn to make it easy to use. Authorization is also completely decentralized. Instead of some central server making all the decisions about who can do what, the rules themselves, like who's an admin or who's just a user, are stored and synced right alongside the regular data. And this is a huge deal because it means the security rules can never get separated from the data they're supposed to be protecting. They travel together. So how does this all work in practice? Well, it's kind of like a diplomatic courier carrying a secret message. Before any data gets sent, it's cryptographically signed right where it was created. When it arrives, every single peer independently verifies that signature, it looks up the sender's permissions in its own local data, and then authorizes the action. If any single step in that chain fails, that unauthorized change is just silently filtered out. Only fully verified data ever gets through. And finally, we have privacy. When you save something sensitive, it gets encrypted with your private key before it's even stored. To everybody else on the network, that data is just complete unintelligible gibberish. It is totally private. Only you hold the key to unlock it, and your device just decrypts it automatically for you when you need it. So when we put all of these pieces together, what do we actually have? We've seen a lightning-fast sync system, a bulletproof fallback plan, and this really robust built-in security model. Let's take a look at how they all combine to create something that's, well, pretty special. And the synergy here is just perfect, isn't it? The Delta Sync gives you incredible speed for that real-time collaboration. The full state fallback gives you absolute reliability, guaranteeing everyone ends up on the same page. And that integrated security manager creates a tough, resilient, zero-trust environment. You see, each piece makes the others even stronger. So in the end, what is this thing? It's not just another database. It's a complete peer-to-peer framework where the core principles of modern security, cryptographic identity, detailed permissions, and real data privacy, they aren't add-ons. They're fundamental, built-in features from the ground up. So I'm going to leave you with this final thought. We've just walked through a system where data doesn't need a central server to act as its bodyguard. It's designed to protect itself, no matter where it goes. So the real question becomes, when our data is this smart and this sovereign, what entirely new kinds of applications and possibilities does that open up for all of us?